Hello and welcome back to the CCENT journey with me, Ryan, and in this section we're going to start a new topic called infrastructure maintenance. It's the last part 5 of the CCENT blueprint. In this part we're going to primarily look at actually logging onto the Cisco and doing the configuration changes. And before we can do that, we need to first of all look physically at a Cisco router, Cisco switch, and make sure that we understand what the ports are for, how we would actually power it on and connect to it using the console, and then we can dive into some of the configurations in later videos. So for those who don't know, you can contact me here on YouTube, on LinkedIn, or Twitter. So let's first of all have a look at this equipment I've got in front of me. Router, a couple of switches, and an access point. Let's just dive in and have a discussion about what we're actually looking at physically and to be able to identify that. You'd be surprised with the amount of engineers passing their CCENT and CCNA and still not able to actually physically see the routers, because so much of it can be done virtually now, especially with obviously home study. But it's great to see many people passing their qualifications without having to invest in equipment. It's just important that we stay connected to that physical world. So we can see just down here we have the console cable. We have two types of console access on this device. We actually have the USB, which is the newer method. It'd be the USB cable with two types of USB, very similar to like phone chargers, and you would plug into the Cisco and the other end into your PC. And then here would be the older RJ45 connector, and on the other side of that RJ45 is a serial. Now, what the console access, marked by the blue color, as you can see across both these ports, what this actually allows you to do is when you obviously buy the Cisco, it doesn't have any configuration on it. So it doesn't have any IPs, doesn't have Telnet, SSH, nothing. So in order to get it up and running, you need to have console access. So you need to get hold of a USB or RJ45 serial cable, plug it into the relevant port, and then plug it into your laptop or PC. And then you would actually use a terminal client like PuTTY, Secure CRT, TerraTerm, get access to the box and then start its configuration. Like for example, you might want to configure the gig 00 or gig 01 interfaces to have an IP address, and then set up the VTY lines to allow Telnet or SSH. But in order to do that, we also first need to have some method into the device, which is where console comes into play. Gig 00 and 01, these are obviously two layer 3 interfaces that you can put IPs against it, and then underneath those interfaces there are actually a couple of USB ports. Those USB ports can be used for file transfer. So if you have a iOS, an actual image that you want to put onto the device, then you can actually put that software on using USB rather than FTP or TFTP it across. Understanding an iOS, how to manage it, as in upgrade, downgrade, delete, navigate flash, and how we can utilize USB, we picked up in a later video. Just above the console we have the aux or auxiliary port, and this is normally used to connect to an external modem, and then you can use that modem to connect into the device. So let's say for example you accidentally shut down a port that you had telnetted through. Let's say you telnet to gig 00, you go in and instead of shutting down 01, you shut down 00, and you want to gain access to the device remotely. Well, if you had the auxiliary port configured to a modem, then you could have a sort of a on-demand backup, if you like, to get back into that device to then re-enable the port you've accidentally disabled. Sometimes it's referred to as an OOB, out-of-bound management, but what you tend to find is a lot of people have a dedicated OOB device, and then that device then has access into the consoles. Now, what exactly is an OOB is outside the scope of the CCENT, so I won't spend too much time there. But if you're interested, go and have a look at out-of-bound management. We also have just under here, we have a bunch of actual NIMH modules, or EHWICs as they're called here. And the NIMH modules are basically network interface modules, and they allow us to expand the Cisco. And what I mean by that is, in this particular scenario, we've actually got a VDSL, ADSL or POTS card, and this is physically RJ11 output, and in the UK we use the RJ11 to terminate ADSL, along with different flavors of ADSL like fiber. Now the port itself, because it has VDSL and ADSL capabilities, is able to terminate different flavors of DSL, and therefore making it very flexible. Not only do we have ports like WAN connectivity, but we can also get things like switching modules, so we can have a 4-port, 8-port, or even additional fiber ports as switching capabilities inside these NIMHs. Along with that, we can actually put things like voice iOS, or even in some instances things like IPS, and put a security iOS on it for something like a zone-based firewall with additional features. Each bit of hardware is very flexible and unique, and you need to use the Cisco documentation to understand which NIMHs and which expansion bays can be used with which hardware. There are also a variety of different sizes when it comes to expansion bays. In this particular model, we can see that they're all just a single width expansion, and there's a couple of them as we can see. So moving on to a switch. This particular switch is a Catalyst 2960C, and this also has, if you noticed, many more ports as we would expect by a switch. And in fact, if I pull this port out, we can see that there's actually 2 ports that look a bit different to the rest. These top 2 right ports, as you can see, are not RJ45. They're actually ports that allow us to put what we call a SFP module in, and that SFP module terminates a fiber connectivity, just like we talked about in the physical components video. So here, what we'd normally see in this scenario is port 1 to 8 for our end clients. So they're going to be most likely access ports with single VLANs. And then 1 and 2 will be our uplinks to a distribution switch. Now that doesn't mean you have to use 1 and 2 as uplink ports. You can use any port. It's just normally separated like this to make the installation easier. Maybe it's because the 2 uplink ports are actually faster. Sometimes it doesn't really matter which link connects to the distribution, but obviously if there is one faster than the others, it makes sense to do that, because it will be obviously putting together all the aggregation of the access ports. And what I mean by that is, of course, if all your ports towards your clients are 100 megabits per second and you've got 10 of them, then obviously they can accumulate to a gigabit per second. So we want to make sure we have that much bandwidth available upstream, assuming that your clients are obviously going to be that bandwidth hungry. One last thing, you'd also see that the 4 ports on the right hand side are labeled 1 and 2, and the reason for that is because it's either port 1 could be fiber or copper, and port 2 could be fiber or copper. It can't be both, and you set in the configuration what you want that port to be. And over on the left, just like we have on our routers, we've got the console access. And again, because it's a newer device, we have both the USB and the older RJ45 for console access. We also have the mode button on the left hand side. Now this is actually used for a few things. First of all, it's used for actually controlling what the lights on the Ethernet ports represent. So by default, it's set to status and system. So it tells us whether the system's green and whether all the ports are in the right state. So are they up, are they down? And that's represented by color. And also you've got the option to toggle the duplex and speed. So if there's a duplex or speed mismatch, something we've talked about in a previous video, then you could press the mode button a few times, and if one of the ports come up red, then it might indicate that it's half duplex. The other thing it could be used for is actually factory restoring the switch back to the default configuration. Normally, by keeping your finger on the mode button for X amount of time, the configuration is wiped. Obviously, this is a security concern, so there is options to disable that within the configuration. Next up, we have another switch. Hopefully you can tell it was a switch based on that port density again. This is an 8-port switch with 2 additional ports that can be used for a fiber. We can see on the right hand side there, we have 2 ports for SFP modules, and then obviously once those modules are installed, we can connect our fibers into that. Notice that there's no console port, and there's not one on the back either. The reason for that is because this particular device doesn't have console access. In fact, the way it works is once you connect it to a network, it uses DHCP to assign itself an IP address, and then it connects up to the Meraki cloud and downloads its configuration. So it's a little bit different, still from Cisco. It's just a different area of Cisco. These are becoming more and more popular, especially for, you send an engineer out on site, he doesn't have any configuration to worry about. Long as the switch is able to obtain an IP address, it can be configured by the cloud if you like, or a remote engineer who's built a template configuration, and it can be easily deployed across a bunch of branch offices very easily. I thought it'd be worth showing you this one because it doesn't have console ports and it tends to get a few questions asked to why it doesn't. The device on the top then is a access point also for Meraki, and again this doesn't have console access either, and both the switch and the AP you can access locally, but you actually have very limited options. There's no CLI that you can actually gain access to with these type of Cisco devices. Here is the USB console cable that Cisco supply. It's a USB B mini at one side, at least I think it's a B mini, and a typical USB A at the other for the PC. So you can see here, this is a USB to serial adapter, because these are the older console cables with serial on one end and RJ45 on the other. So let's move over to PowerPoint and confirm what we've done. Right, so here we are. Let's have a discussion around routers just to start finishing off and ensuring that we have learned what we should in this lesson. So first of all, can we physically identify a router? Well, we know that routers have less port density than a switch. That's the most obvious thing when looking at a device. A router normally has sort of 2 to 4 ports, whereas a switch tends to have a lot more ports because, of course, that's where our end clients sit. Now, that's not always true, but it certainly is at the CCENT level and CCNA, and it certainly is when we think about the smaller branch office equipment. What are console ports and are they on routers? Well, yep, we looked at the router and we were identifying console ports, and we've actually gone one step ahead and physically looked at some console ports. There are also the RJ45 directly to USB without using that adapter that I showed you, but I didn't have one of those cables spare at the time. What are console ports? Well, we know now that they're used to gain access to the Cisco to do the initial configuration, because when you first take the Cisco out of the box, obviously there's no IPs, there's no Telnet, there's no routing, and there's no switching in the switching case, no VLANs, etc. So we need a method to log into that Cisco while it's actually on our desk and configure it. That's what the console port is for. We know they're on routers and they're represented with the blue color. So you notice that when I was showing you those colors on the router, they had blue for console, yellow for the gig fast Ethernet ports, and they had black for the auxiliary port. So the aux port, we said, that is also on a router and it's used for out-of-band management. You would plug a modem in there, and if you accidentally delete the IP of an interface that you were telnetting in, you could bring up an on-demand modem and get back into that device. Routed ports. What do I mean when I say routed ports? Well, they have layer 3 capabilities. We could put an IP on that interface, we could actually create sub-interfaces on it and terminate VLANs, like terminate a trunk to it, or we could configure routing on that port. It's also worth your time to actually go to the Cisco website and have a look at some of their branch routers. Obviously, you don't need to know about the individual platforms, but it's important as an engineer that you're able to look at a router, identify the differences between one and another, whether that's the speed or something, and to identify the difference between routers and switches. Modules and expansion bays. So we've seen that the 2900 that we looked at just now, the 2901, it had the XDSL expansion bay that gave us VDSL and ADSL connectivity, but it also had the ability to have the SFPs installed, and within those SFPs you would have fiber connectivity. So they had different modules and expansion bays. It's important to understand that some routers do have expansion capabilities, and again, on the Cisco website you can have a look at what's called the data sheets, and in there it will identify which bays are available, or which expansions are available, and what feature set and part number, etc. you will need for that. So console cables and the different types of those, we've seen that. I won't bore you. That's not something you need to remember for the exam, but it's certainly important to understand how they physically connect to your PC and how they connect to the Cisco. And it's also important to be able to identify a console cable. This is a interesting box. It's a Cisco A87VA, and this particular box is a router and a switch in one. You can see we have the console ports as you would expect, but the console port is also the aux port in this scenario. We have two different types of power outputs. We have AC and DC. We have 4 ports here, and they're fast Ethernet ports represented by that yellow color again, and these are actually switch ports, so they don't have routing capabilities, but you can create SVIs, and of course on an SVI you can put an IP address and then route between those SVIs. And then over here on the far left we have a RJ11 connector, or sorry, RJ11 port, and this is for the ADSL and VDSL, very similar to what we've seen previously with the 2900 expansion bay. So this device is actually both a router and a switch in one. Moving on then to switches. Can we physically identify a switch? Well, I'm sure we can now. The first giveaway is of course port density. Here's the example of the 3700s. You can see that there are different switches inside this series of routers, and you can see straight away that there are different port densities and different fiber options on the right hand side there. So happy we can identify a switch. What are console ports and are they on the switch? Like I said, we discussed this previously. We know what console ports are. Are they on switches? Yes. But can you see them looking at this switch? Nope. And did we see the console's ports in the videos? We did. We saw it at the front. However, most of the time it's actually at the back. So yes, they have console ports just like a router. Mode button. You can see right here on this guy, he also has a mode button, and just here there's a little legend that tells you what the lights are going to represent. So if we plug in a couple of these ports down to our end clients, and then one of these ports for whatever reason done the negotiation at half duplex, then what we can do is we can press this mode button, and these lights up here, normally they represent if something is plugged in, and if it is plugged in it will go green or it will flash. But when we press this mode button, that light will represent something different. So we press it a few times, it might then show us green for all of the ports running in full duplex and red for this port running in half duplex. So we know what the mode button does. Switch ports. So unlike a router with routed ports, in this scenario we get switch ports. Now when you get into your CCNA, you get to actually turn switch ports into routed ports if the device is capable of doing it, and the same can be said here with this switch. So this particular switch has layer 3 capabilities, so you could go to a particular port and turn it to a layer 3 routed port and have routing capabilities, but it will depend on the software and hardware that you purchase from Cisco to whether it could be routed or switch ports. Obviously, if it's switch ports, then it has layer 2 capabilities, so it could be inside a VLAN, it could be a trunk, We need to put in things like port security into considerations, stuff we've already talked about in the past. Modules and expansion bays, not so much on the lower end devices. So these are part of what Cisco calls the access switches. Remember, we had a discussion around access, distribution and core. Well, these are part of the access family. So the lower end, high port density, cheap cost, and you'll get a bunch of them in a rack to terminate everyone in the office. And then they would normally uplink here to the distribution layer. But not so much modules and expansion bays at this lower end of the spectrum as far as switches are concerned. Routers can be very flexible, as we've seen. Switches, not so much. That's not true though, as we progress up the tree, if you like, to a bigger, beefier switches, to something like the Catalyst 6500s or whatever you want to look at. Those come with, well, they're basically built on a modular fashion. Every single line card, supervisor and so forth is built around the ability to become module. But that's outside the scope of the CCENT and CCNA. And console cables and console types, they basically, obviously, well, like I said, they use the same consoles as the router. And when we actually log on to a physical device using the console, you'll see it uses the same terminal settings as well. So I appreciate there's been a lot of repetition in this video. I feel like I've been repeating a lot of stuff, but at the end here, I thought I'd just put a review and say we looked at some stuff. We looked at routers and switches physically, something we've not done yet in the course. We identified their ports and what those ports are for, and we haven't actually plugged anything in and played with them yet. We'll be doing that as the series continues. What I would recommend doing now is actually go to the Cisco website, have a look at their branch routers, the low-end routers, and get familiar with the makes, models, and the data sheets, comparing them. So look at the 800 series or the 1000 series and compare the differences inside those series. Also, do the same for switches. Go look at access switches and again, compare and contrast the difference between them. Now, you won't get tested on the exam about models and hardware, but it's always good to have a look at those data sheets and see if you can understand the differences between those devices, and in turn, it will help you identify those devices as you move forward in your studies and as you progress throughout your career. I hope this video has been informative. Obviously, it's a little bit different than what we've done in the past, and it will continue to change as we finish up with the CCENT series. If it has been helpful, please do like and subscribe.